So, hi, and welcome to this month's Gramene webinar. My name is Joseph Mulvaney, and I will be speaking with Andrew Olson about two new Gramene search interfaces. So the first one is this search.gramene.org, which I'll talk about, which is a website where which you can use to search and explore the data sets that Gramene holds. And Andrew will talk about data.gramene.org, which is the web service backend, which is kind of like the kind of more machine-readable API for software developers and bioinformaticians to use. Yes, and before I dive in, I have some technical tips here. So if the video is halting, then select a lower quality stream from the drop-down menu at the top left of the video window. You can watch full screen video by clicking the video with 4 arrows at the top right. And you can ask questions using the chat panel below the video window. And I will be alerted to any questions and we will try and deal with any issues that arise through that communication mechanism. Okay, so today I'd like to introduce, I'm sure many of you are familiar with Gramene itself, but I'm going to introduce it in the way that I like to think about it, kind of introduce the problem that we were trying to address, and then I'll talk about the Gramene search interface, and then Andrew will take over and talk about the web service interface. So, what is Gramene, or what is in Gramene? So Gramene is a database of information about the genomes and other genomes and pathways and expression data for agriculturally important crops, and it's made up of a number of significant and important parts. So we have the genomes. We collaborate with Ensemble, EBI Ensemble, and we share the work of loading those into an Ensemble instance, which is both here and in Europe with Ensemble plants. We have metabolic and regulatory pathways in the plant reactome software infrastructure, and we have a number of other data sets, including expression in other data sources that I won't talk about too much. But really the point that I want to make is that we have some really great data in best-in-class software tools, but they're kind of siloed. They're in separate places. We've got the genomes in one over here, and in a fairly separate software infrastructure, we have the reactome over here. So really what we wanted to do was create a search interface where you could easily search across all of these things, find what you need, and then go from the search interface to the specialized tool that you wanted to use. I'm just going to briefly talk about this from, I'm a software developer, I should say. So I tend to think about this in terms of software components. So we have here in this green column, we have databases. We have Ensemble and Plant Reactome in two kind of separate databases. And then we have services, so the web servers, and then tools, which users would use, like yourselves, who probably use Ensemble, and you may be also familiar with Biomart. And the plant reactome. So what we really tried to do was kind of take all that data and put it into a data warehouse. So we have our own database, which we pull not all the information, but kind of high-level salient information we can build to get, which we can pull together and build into these cores for genes and families and pathways and ontologies and domains. And then we have our own web service interface that Andrew will talk about later. And then on top of that, we have a new search interface, and we've also made it so that we've made it so that other people can easily use those tools as well. Yeah, so I'd like to talk about the goals of the search interface that we built. We wanted to be able to search all of the Gramene data. We wanted to make it possible to ask interesting questions, so powerful searches. And really summarize, make it so ask interesting questions and summarize data, even if you have a very large data set. And then to link out to the specialized tools once you've found the things that you're interested in. And to make it really fast, and also over all of this, really, we wanted to make it easy to use. So this is what it looks like. When you get to the front page, really the key thing that you should notice is that there is one search box. And that's really the interface that you'll be working with. And also notice over here that when you go there for the first time, what you have is all of the genes, all 1.7 million genes in 39 genomes. And what you're doing really is filtering. And what happens when you, so this is not exactly like how Google works, but you'll see. When you start typing, so let's say I type the 3 letters here, ARA. We try and make a good guess about what you are really asking for. And so our top suggestion, we provide a list of suggestions as you are typing. And our top suggestion here is Arabidopsis thaliana. But in this case, I was actually interested, this is a slightly contrived example, so bear with me. I was actually interested in this gene ARA3, but it's there for me already, so I'm going to click on it at this point. And so what happens when you click on a suggestion is that you get presented with your search results. And you can see that the text has disappeared from the search box. There is a new filter right underneath it where it says what you are searching for. You can see that the results have filtered right down. You can see there are 8 genes in 3 genomes. And then now underneath you don't immediately see a list of results. What you see is a visualization. What you see is all of the results that you found with your search, but they are distributed over all of the genes, over all of the genomes that we have in Gramene. So I call this a taxogenomic distribution, which is not necessarily it's not a very easy to say name. Really, the point is that on the left there is a taxonomic arrangement. It's a species tree of all of the genomes that we have. And then on the right, we have linearized and really condensed down. This is a representation of the genomes in one line. And really, so really the first colored part is the first chromosome. This is the second chromosome. This is the third chromosome. The gray parts are unassembled pieces. So some of the genomes, unfortunately, you can't see exactly where the genes are distributed. But here, I hope that you can see that of those 8 genes, 6 of them are in Brassica rapa, and they are distributed like this. And then the other 2 are down here. But that's really but you can see where they are, really, and how they are distributed across our genomes. And then underneath that, we actually do show you a list of those results. And the way that so for each result, what we show you is a short identifier, if available, the long identifier, the species, a description, and this column over here is a little more interesting, I think. So for Arabidopsis, TARE actually have some really nice curated descriptions of the gene, which were made by humans. And we found that these to be pretty useful summaries of what the thing that you have found does. And for genes in other genomes, what we do is we use homology modeling using the Ensemble's Comparer database to find the most closely related gene in Arabidopsis, because they typically have the best annotations. So even though the gene that you found is this, this isn't the worst genome for this, but because you do get some information in the description, but we've tried to provide you with more information over here. And then underneath each gene, you can see these 3 links, which are actually expand into tabs of information. So let's imagine that I click on this location tab, and then you can see that the shape of this this gene. You can see that there are three transcripts. You can see you are told where it is. And then below here, you can link to other resources. So if you want more details about this gene, then you can jump to Ensemble Genomes at this point, or Phytomine or Araport. And also, so these boxes over here where it says search Gramene, these are deliberately intended to look like the filter boxes that you get when you pick something from a search. And the idea here is that when you click on one of these, then you actually will be able to see, you change the search, you kind of start exploring the data. So once you've found one result, you can expand to other things of interest. At least that's the concept here. So I'm actually going to run the risk of a live demo at this point. I'm going to talk about some of the more interesting features, some of the, like taking what I've already told you and kind of expanding on those. So one of those things is that you can compose queries from more than one filter, and it's very easy to do. So for example, this is a simple one here is that if you were interested in genes that are involved in the jasmonic acid biosynthesis pathway, but only those genes so annotated in dicots, then you could very quickly get that list of genes. And so I'm going to click a demo over here. I should say that this tool is, oh, I've opened it twice. There we go. This tool is available at a simple URL, which is search.gramene.org. I'm a software developer, and I have recently added new features to this, and I really wanted to show you them. So if you manage to make a note of this URL, we may share it later. This is a live version of the site, but it uses some testing features. It uses some features which aren't quite ready for production, but I think are really cool. So we are interested in, so jasmonic acid. So I'm going to start typing Jasmo. Okay, and there are the suggestions. They came in relatively quickly, so we can click jasmonic acid biosynthesis, and you should see here are all of the genes which have been annotated from the plant reactome as being involved in jasmonic acid biosynthesis. And let's say, okay, so we are interested only in those in dicots. So now the top suggestion that's been suggested is the appropriate taxonomic node to filter just to dicots. So you can click on this, and you will see those results in jasmonic acid in the dicots, and there they are, and here they are down here. And you can see now, so we slightly, it's an interesting question is that what order do you present the results? And the answer is once you have a query terms, the order that you present gene results is a little bit arbitrary, and we have chosen to promote Arabidopsis over the other genomes simply because they tend to provide the most useful information. And so you can see here also we have these curated descriptions which give you a nice summary of those genes. So let's look down here. Let's pick this one, and let's have a look at the homology tab instead of the location tab. So this is something which I haven't shown you yet. So this is showing you some more detail of the compara gene tree. And the compara gene trees are created by Ensemble when they do a new release, and basically they infer the relationship, the homology of the kinds of homology of genes, all transcripts in the Ensemble database that you're working with. And so here, and then it assembles them into a tree. So here is the gene which you are looking at, which we are looking at here, Arabidopsis thaliana OPR3, and you can see how other genes and we don't show the full tree initially because they're very large, but you can see that. Let's have a look. So here are the ones from Brassica down here. So you can see there are 2 more genes here, and we kind of animate this, and these expand dynamically and are very fast. And this, so if you're familiar with the Ensemble gene tree view, which I will just jump over to right now, it's a little bit slower. Maybe I'll let that load. So this alignment part with the green part down here, the green parts here, which show you where in the multiple sequence alignment there is a match for each of these genes, is the same. But in addition to that, you can see these are interpro domains colored over the top. So if you click on one of these, you can see which interpro domain that is, and you can see that this is kind of a signature of this gene tree in the sense that 90% of the genes in this gene tree have this aldolase-like Tim barrel structural annotation. I should add, this is a pretty new feature, and we will be making this as a kind of, we'll be adding search features so that you can take this information and then jump up here and filter down to just that domain, but we haven't done that yet. So yes, let's see if this is open over here. So you can see that this is the same gene tree that is present here. We open it in a similar way, and we have a similar kind of alignment part. That's all I wanted to show you, and that we jump to it from this link. Okay, let's go back to the presentation over here. So, okay, this is another demo, and this is moving on from composing queries. Really what we're doing now is we want to kind of, once you have results, you can use what you've found to jump around and find and explore and find new genes in the data set which interest you. And so in this example, so this is something which is fairly common for I'm sure a lot of plant researchers who are working on a non-model genome. So the curated information about many genes in many genomes is not great, and you often end up referring back to Arabidopsis to get some functional and descriptive information about a gene. We've kind of tried to make an interface which takes advantage of the fact that we've already run BLAST a large number of times when we build the comparer database. So we can quickly we can quickly tell you all the homologous genes from Arabidopsis in another species of interest. So for example, oh, I did that thing again. Let's close that. Okay, so if I type PAD4 up here, if we're interested in PAD4, which is a disease resistance associated gene, you can see that we found 10 genes from 7 genomes which have been annotated in PAD4, and these are massively overrepresented in a small number of genomes. And that seems unlikely from a biological perspective because we know that this is a pathway that's used by at least all the plant species that we have here. And you can see here is PAD4 from Arabidopsis at the top of the results here. And so one thing you can do once you look at the homology tab down here is you can say, show me all of the orthologs. So if you click this button, so note here is the filter that we have right now, but when you click this button, the filter changes from gene PAD4 to gene tree orthologs of PAD4. And if we scroll up to the top of the page, you can suddenly see that we now have 51 genes in 33 genomes, and they're distributed in a much more, in a way that you would much more expect considering the ubiquity of this pathway, with the exception of one rice species. But yes, and that was the point of that. Good. So I hope I've given you an impression of the kind of the mechanics and the way that the interface works, and I really encourage you to have a go and try using it with your own the genes and pathways and domains and Go annotations that you are familiar with and that you know about. We'd really love to hear how that goes. I just want to touch on a few things that we will be introducing soon. We have while you can search on the plant reactome, looking at that data for an individual gene result, it's not finished yet. We have, there's a test version which is not quite done yet. We also like to show expression data integrated into that result view. And also, something that we're very aware of is that Gramene will shortly have significantly more genomes in it. And a lot of the interface that we've built here really isn't going to scale to expand to 60 or 100 genomes. And in addition, a lot of researchers really are interested in the genome that they're interested in, the ones that are closely related to it, and an Arabidopsis and maybe another couple of outgroups. And really, they're not too interested in in other genomes. So we will have a feature where you can really where you can pick genomes of interest, and then the whole interface will be dialed back to just show you information from those genes, from those genomes. Excuse me. So yes. And if you're interested in testing this and would like to talk to us about it, then please do sign up at gramene.org/beta. And an older version of this software, which we will be updating in the next couple of days, is here for you to test at search.gramene.org. Okay. And I'd now like to hand over to Andrew to talk a little bit about the data source that where we get all the data for this user interface. Yeah, that's the web service API. Okay, thank you.
All right, thanks, Joe. So the web service API is available through data.gramene.org, and it, as Joe explained, it powers all of the various searches that are in the website, in search.gramene.org. Looking for the notes. There we go. So we chose Swagger as a technology to provide the backend to the search, because it lets you describe your API in a very rich way, and it also provides a suite of tools which let you, I believe it got, yes. Should I switch to Joe's mic?
Yeah, let's switch mics. I'm not getting on this. It's not going
Okay. Sorry about that. You sure? All right. So if I'll just continue now. So Swagger has it provides tools that let you explore the, define the. All right. Swagger lets you define the API in a consistent way, and it provides tools that let you publish the API through a web service, and it also provides tools for the client side, so that users on the client side, like Joe and anyone else out there that wants to use the API, can use it from any language, modern programming language that they so choose. Yeah, so just to remind you, the Gramene Web Services sit here in the middle. They draw data from primarily directly from the MongoDB and Solr cores that we generate, but there's also a route in there to pull data from the Ensemble REST API, which we also run. So so Swagger also provides a nice route to the documentation for the API. So if you go to data.gramene.org, you'll be presented with this view, and after you click on data access, you can see the various methods that are implemented for accessing different types of data. So if you were to click on genes, you'll be presented with, it's in the same page, but it opens up a set of available parameters. So here's an example where we just set the query string to pad 4, and at the bottom of the page you click try it out, and then you're presented with a curl command that you could then copy and paste into a terminal window on your machine and obtain the results directly, or you can use the request URL directly in writing your scripts, and also it'll present with the response here. This response is in the JSON format, which is what we use in the website primarily, and because it's simple to deal with in JavaScript. Another feature is beyond JSON, we also let you download or pose queries that would lead to bed files. Bed files are useful in a lot of applications where you don't really need all the rich description of the gene model, but perhaps you were just interested in, so in this example, you define a bed feature that you're interested in. So here it's just transcripts and a bed combiner parameter here, canonical, would basically choose one transcript for each gene model, which represents the longest protein isoform. And the taxon ID here, I've put in the taxonomy ID for maize. And so what you should get back is just canonical transcripts for the maze annotations. And yeah, so this is what that result would look like. And here you are presented with a 12-column bed file format. And now in this example here, I didn't specify the rows parameter. If you look up a little bit higher on this page, rows defaults to 20 rows. So if you wanted all of the transcripts in maze, you would put rows as -1. That's a little secret tip I have not documented in this description, but I can add that in the future. So then you could download all of the annotations for maze. So that's it for our end. Just to remind you, the webinar will be posted on YouTube on our Gramene database channel, and you can reach us in these various manners, and we're happy to take questions.